Well, welcome, my brilliant fifth grade mathematicians. We're going to take a look at entry task day 107. Problem number 1. Alicia and Madison are both running in a race. Alicia finishes the race in 3 hours. Madison finishes in 7/9 of that amount of time. The shaded portions in this model represent the amount of time Madison spent running the race. Enter the amount of time in hours Madison takes to finish the race. So the first thing I want to point out here is this second sentence here. We're supposed to find out how long Madison takes to run the race. And it tells us that she runs it in 7/9 of that amount of time. Well, what is that amount of time? It is 3 hours. It's the time that Alicia took. So what I'm going to do is I'm going to set up a multiplication problem. 7/9 of the amount of time that Alicia took, which is 3 hours. Okay, so if we were to solve that, it would be 7 times 3 over 9. I'm going to do some cross canceling because I know that 3 goes into 9 3 times, and 3 goes into 1 1 time. So that is equal to 7/3, which is equal to 2 1/3. Now before I write my answer, and we know that that is in hours, before I write my answer, I want to take a look at our diagram here. Okay, so because it says the diagram matches the amount of time, so each of these circles has 7 portions shaded, and that is equal to 21 what? Okay, well, if we look carefully, there are 9 pieces, so this would be 21/9. Now, 21/9, if I simplified that, I see that 3 goes into 21, and 9. And I would get 7/3, which is the same as 2 1/3, which is what we figured out when we set up our multiplication problem. So, Madison ran the race in 2 1/3 hour. Now, if we did an estimate, what is, so 7/9 is not quite 1 whole, right? So all of, or 1 whole of Alicia's time is 3 hours, so this is not quite 3 hours, if that, if you're following my estimation there. So the other way we could think of that is maybe we look at 7/9 and we think, oh, it's about 2/3, and 2/3 of 3 is 2. So again, when we do estimation, we're looking for things that would get us in the ballpark, that they would be close, to help to see if our answer makes sense. Okay, problem number 2. Enter the difference. We have a problem that says 2 3/10 minus 12/10. Well, the first thing I know is as I'm subtracting here, they have the like denominators already. So I'm simply going to be subtracting, and I know that I'm going to have to borrow. So if I have 2 3/10 minus 12/10, I have to borrow from the 2, and that is going to give me 1 whole, and I take the other whole and I make it into tenths. So I have 1 whole and 10/10, that equals 2 plus 3/10 minus 12/10. So that'd be 1 13/10 minus 12/10. I can subtract the fraction, and that leaves me with 1. Whoops, why did I do 10 or 12s there? Change that. That leaves me with 1 1/10. So 1 1/10. There we go. Problem number 3. Danny has a fish tank in the shape of a right rectangular prism. The edge lengths of the prism in inches are 9, 16, and 20. Enter the volume in cubic inches of the fish tank. Well, we know that when we're finding volume of a rectangular prism, it equals length times width times height. And we are given 16, it doesn't matter what order, so let's go 20 times 9 times 16. Okay, so I can multiply those in any order. In this case, I know that 20 times 16 is 320, because I know 2 times 16 is 32. So I'm going to have 320 times 9. And 320 times 9 is 2,880. And it is in volume, so we have to give the correct unit of measure, 2,880, and the measurement is inches cubed. There we go. Okay, problem number 4. We have a conversion problem. It says enter the number of meters equal to 10,000 centimeters. So with a conversion, we're going to write what we have, 10,000 centimeters, and it wants to know how many meters that is. Now, as a general rule, when I'm going from a smaller unit of measure to a larger unit of measure, smaller to larger, you're going to divide. So I know that 100 centimeters equals 1 meter. So I'm going to be dividing 10,000 by 100. Okay? And when I do that, I end up with 100. So 10,000 centimeters is equal to 100 meters. And problem number 5. Which statement describes the value of the expression 500. Well, actually, when I take a look at this, we want to think of what's in parentheses as one thing. Okay, because remember, parentheses tell us what to do first. So if I was solving it, I would find the difference between 500 and 435. Then I would find the sum of 70 plus 5, and then I would multiply to find the product of it, of those two quantities. So let's read statement A. The value is the difference between 500 and 435 times the sum of 70 and 5. Well, that's basically what I just explained. If we look at this first set of parentheses, that's the difference of 500 and 435. If we look at the second set of parentheses, that's the sum of 70 and 5. And what am I doing to those? I'm timesing them. So there we go. So one of the things when we have these types of problems, we want to think about what's in parentheses and think of our math action words. So until tomorrow, have a great day.